Welcome back. In today's problem, we have a inverting amplifier, and it's constructed with R1 and R2, which is our normal topology, which is R1 is our input resistance. That's a resistance value of 1K. Our feedback resistance is 10K, and for a closed loop gain of 10, negative 10, and a load resistor RL, which is equal to R2. So RL is 10K, R2 is 10K. We're asked what is the current through R1 from the V in source. So we're going to find I in, which is equal to IR1. Also, what is the current into RL? So in this case, we know that the current I in flows from the V in source. We know by virtual short that I minus and I positive or I plus is equal to 0 amp. Also, if no current flows into the V minus terminal, thus we know that I in is equal to the current flowing through IR2, which is equal to I in. At this point, we pick the direction for the current through RL. We choose a direction. This may not be right, but we still choose. And we also choose that, let's choose that the output current flows from the output of the op amp. We stated earlier that by virtual short, we have that V minus, the voltage at V plus can be assigned to the V minus terminal, and we see that the voltage at V plus is equal to 0 volts, which is equal to V minus. By a virtual short, we know that I minus is equal to I plus, which is equal to 0 amp. So to find, so we use voltage division. So to find V out, in our case, we use voltage division and use the midpoint of the voltage divider equation to find V out. So in this case, the midpoint is going to be 0 volts. So we can then go ahead and say that if we set V minus to 0 volts, and by superposition, this is V out. By superposition, if we set V out to 0, we then take the voltage across R2. So if V out is 0, we then take the voltage across R2 with reference to V in by using voltage division. So the voltage across R2, so that's R2 divided by R2 plus R1 times V in. Then we set V in equal to 0, take the voltage across R1 with reference to ground, and we use voltage division to do so. So that is R1 divided by R1 plus R2 times V out. So that's by superposition. And because this was V minus and we set that to 0, we can then solve for V out. So if we multiply both sides of the equation by R2 plus R1, or R1 plus R2, doesn't matter which way we have them, we then get that V out is equal to negative R2 divided by R1 times V in. The gain of our inverting amplifier is then equal to AV equals V out divided by V in, which is equal to negative R2 over R1. Knowing that, we can then move forward and say, first of all, let's find the current. So let's find the current. What is the current into R1 from the V in source? That's how we figured out the direction of the current I in. So we can then find I in. We know that the voltage, if we can find the voltage across the R1 resistor, we can then find the current flowing through that resistor. So the voltage across R1, so we do that by KCL. So we can say I in is equal to the voltage across R1 divided by R1, which gives us current. So we can say that V minus, or in this case, V in, but we'll say Vin minus V minus divided by R1 is equal to, we know that by voltage, not by voltage, by virtual short, we know that the V minus terminal is held at ground, which is 0 volts. So that is Vin divided by R1. Vin is 1 volt. So thus R1 is equal to 1 milliamp. So the current through R1 is equal to 1 milliampere. We then go ahead and check for the current through RL, which is the load current. So B is equal to IL for load is equal to the output voltage. So if you notice here, if we can find the voltage across RL divided by RL, we get the current IL. We know the voltage at Vout, and we know the midpoint between the power supply voltage is ground because the load connects to ground. So basically we can then go ahead and say Vout divided by RL is equal to, and as you can see over here, Vout is equal to R over R cancels out, and that is equal to 10 volts. R2 divided by R1, negative 10 volts. So we can then go ahead, negative 10 volts. So that negative 10 volts over 10K, that is 1 milliampere, which is negative 1. So that's negative 1 milliamp. So the load current is 1 milliamp. We can then look, or let's do C. So for C, we're asked to find, so apply KCL at the Vout terminal. So let's apply KCL at the Vout terminal. And then they're asked, by the way, we're asked to where does the output current flow in this circuit. So we need to figure out the direction of I0, which is the output current. And if we see that the load current is negative, that means the direction for the load current should be opposite from the one we have. So we can then go ahead and say for C, apply KCL. So the load current, in our case that we have here, is equal to, we have In coming into that junction, and we have IL going out. So coming in is negative, so that's negative In, and going out is positive, so that's plus IL. We know that the input current is 1 milliamp, so 1 milliamp, so that's negative 1 milliamp, plus IL, which is a negative again, so that's negative 2 milliamp. So I out is equal to negative 2 milliampere. So if I out is equal to negative 2 milliamps, we could then go ahead and change, well, we don't have to change the direction, but we know if it's negative, that means IL flows this direction, and I out flows this direction. So thus, we would say that when Vin is positive and Vout is negative, current will flow from Vin. So we see that current is flowing from Vin, and it flows through R1 and through R2 because the current into the V minus or V plus terminal is 0 amp, so no current flows through that way. So therefore we have In flowing through R1 and R2 and into the output terminal of the op amp. So therefore In flows into the output terminal of the op amp, and that's why in this case we have I out flowing this way, and by I out flowing this way it is negative because it's flowing against the correct convention. So we can then go ahead and say, to where does the output current flow in the circuit? We can then say if it's flowing from positive, we know that current flows from positive to negative. So if it flows from positive to negative, ultimately that current flows to the negative power supply. So that means it will flow into V negative. And if it flows into V negative, notice that this current should be flowing in the opposite direction, and thus would prove that IL would be positive, and this should be the right direction. So if it flows this way, it's positive. So therefore, the current for this, the output current flows into the output of the op amp, and I in the current from the V in source flows through R1 and through R2 to get to the output terminal. Also, conversely, when V in is negative and V out is positive, current will flow from the op amp output terminal. So in this case, if V in is negative and V out is positive, current will flow from the output of the op amp, and ultimately that current will originate in V positive and thus flow through R1 and R2 into the V in source. So that would be this. We would see the current flowing in this case, and it would flow through the load, then flows this way, go this way, and because it can't go into V minus by virtual short, 0 amp, no current flows into V minus, it would then flows into the input source, and that would be sort of charging a battery or something like that. So that's it for this problem. So see you next problem. Bye.